Hi guys, this is Mohan. Welcome to the session. In this session, we are going to discuss string buffer and string builder. First, let us see what is the limitation in strings, guys, when we have more concatenating operations. Guys, as we all know that strings are immutable, which means once you're trying to add any string to existing string, it will not be added, it will create a new object. Let me show you the example. I have a string Sachin. I'm trying to add Tendulkar. It will create the new object called Sachin Tendulkar. This Tendulkar will not be appended to the existing string called Sachin. Similarly, when I'm trying to add again Tendulkar to Sachin Tendulkar, it will create Sachin Tendulkar, but Tendulkar will not be added to existing string Sachin Tendulkar, etc. Which means whenever you're trying to concatenate, you're trying to add some string to existing string, each request will create a new object. Assume that guys, you have more number of concatenation, around 1000 concatenations. Each time it will create that new object. So 1000 objects will be created and it will degrade the performance. So obviously we need something which is alternative to string, that is mutable string. That is called as string buffer. Guys, these are the topics we are going to discuss as part of this session. This is what just now we discussed. What is the disadvantage in string when we have more concatenating operations? What is string buffer? Different constructors present in string buffer. All important methods present in string buffer class. And prove the how do we prove that string buffer is mutable? What is the limitation or disadvantage in string buffer? What is string builder? Different constructors present in string builder. All important methods of string builder class. And string builder mutability test. String versus string buffer, that is the differences between string and string buffer, differences between string buffer and string builder. Guys, first let us see string buffer, then we will discuss the string builder. What is string buffer? Java string buffer class is used to create mutable or modifiable string. The string buffer class in Java is same as string class except it is mutable, that is it can be changeable, and it is synchronized class. Guys, string buffer is synchronized. What do you mean by synchronized? What is synchronization? What is synchronization is whenever one thread enters into synchronized method, until it exits, it will not allow other threads to execute. Or otherwise, synchronized methods are thread safe, which means at a time only one thread can execute the synchronized method. So almost all methods present in string buffer are synchronized. So we'll call the string buffer as synchronized class. Let us see the constructors present in string buffer class. Guys, there are three constructors present in string buffer. One is default, another one you can provide the string, another one you can provide the capacity. How this default string will work is, whenever you say string buffer, let me show you this. String buffer sb1 is equal to new string buffer. The string buffer will be created with capacity of 16. Next one. When we try to create string buffer sb2 is equal to new string buffer of Sachin with 6 characters, then the string buffer will be created 16 plus 6 22 capacity. And third one is string buffer SB3 is equal to new string buffer of capacity, that is 25. So in this case the string buffer will be created with 25 capacity. Let me show you a demo, guys. These are the three different constructors. I am using default constructor here string constructor, here I am providing the capacity. In first case, string buffer object will be created with capacity of 16 because we are using default constructor. Second one, we are providing the string with 6 characters, 6 plus default capacity 16, and in this case string buffer will be created with 22 capacity. In third case, we are providing the capacity that is 25. So string buffer SB3 will be created with capacity of 25. Default, second one string constructor, then capacity, that is int capacity. Let us see few important methods present in string buffer class, guys. Public int capacity, this is used to return the current capacity, and whenever we are trying to add more elements than the capacity, then obviously the capacity will grow. Let me show you guys how it will go. Guys, I am creating the string buffer with a default constructor. String buffer SB is equal to new string buffer. If you print the capacity, we call the capacity method, it will print the capacity of that string buffer. In this case, default capacity is 16, and I'm going to append 5 character string. This will increase the capacity of the string buffer? No, because the string buffer capacity is 16. Within that range you are going to add the string, so it will never grow. If you print, it will again print 16 only. But I'm going to append sb.append. Java is my favorite language. Some big string which is greater than 16 characters. Guys, whenever we are adding elements more than the capacity, more than the existing capacity, then string buffer has to grow. String buffer has to increase its capacity. How it will increase is, there is a formula. What is that formula is? Old capacity into 2 plus 2. What is the old capacity here? 16. 16 into 2 plus 2, that is 34. Here it will print 34. Guys, let me repeat once again. In this case, we are creating string buffer using default constructor. So the default capacity is 16. Within this capacity range, if you add any string, then the capacity will not grow. If you are adding the elements beyond the capacity, then the capacity has to grow. How it will grow is existing capacity into 2 plus 2. In this case, that is 34. 16, 16, 34. Next one, guys. Append is used to append the specified string with the existing string. The append method has overloaded methods. I have a string buffer such in, whenever you are going to add, if you want to add any other string, you can use append string, sb dot append of string. It will append, it will add this Tendulkar to existing object, existing string buffer object called searching. So searching Tendulkar. Before that I am printing, before adding I am printing, after adding I am printing. Guys, this append has the overloaded method, meaning see this append boolean, you can append boolean, you can append double, float, int, long, string. So this append has the overloaded methods. Next one, insert. If you want to insert any string, you can use this method. Public synchronized string buffer insert int offset. Provide the index here where you want to insert and insertable string. This also has the overloaded method, guys. I'm creating string buffer sb is equal to new string buffer of Sachin Tendulkar. I'm printing it. I'm trying to add Mohan at index number 2, that is 0, 1, 2. Here Mohan will be inserted between A and C. I'm printing it. Let me run this program. So original string buffer is Sachin Tendulkar, and we are trying to add at second index, that is this place. So Mohan will be inserted between A and C. And next method is replace. Public synchronized string buffer replace start index, end index and replaceable string. So this string will be replaced between start index and end index, and start index is inclusive, end index is exclusive. Replace. So this is my string buffer Sachin Tendulkar. I am printing here. I am going to replace with Mohan between 2 and 6 characters. What is 2 and 6? 0, 1, 2, 3, 4, 5, 6. But 6 is exclusive, right? So Chin will be replaced with Mohan. Now see guys, Chin will be replaced with string Mohan. Next, public synchronized string buffer delete start and end index. It will delete the characters present between start and end indexes, where start index is inclusive and end index is exclusive. My string buffer SB is equal to new string buffer of Sachin Tendulkar. Printing this and deleting the characters between 3 and 7. 0, 1, 2. So 3 means 3, 4, 5, 6, 7. 7 is exclusive. So HIN space will be deleted. HIN space will be deleted. See, SAC Tendulkar. Next one, public synchronized string buffer reverse is used to reverse the string. Guys, I have a string buffer SB is equal to new string buffer of Sachin. I am printing it and call the reverse method. This reverse method will reverse all the characters present in the string. My original string is Sachin. it will print NIHCAS. Guys, this is original string, this is after reverse. Next one, public void ensure capacity. Guys, this is very important method, is used to ensure the capacity at least equal to the given minimum. Guys, let me show you. I am creating string buffer using default constructor. As we all know that the string buffer will be created with capacity 16. I am going to add 6 characters. Do we need to increase the capacity? Are you expecting your string buffer to increase the capacity? No. Why? Because the length of the string which we are going to append here is 6 characters, but the capacity is 16. It will not grow. It will print again 16. Now I am going to append some big string which is greater than 16. SB.append. He is legend cricketer. It has to grow. The capacity has to grow. Whenever we are going to add the element beyond the capacity, then the capacity has to grow. So how it will grow? There is a formula. What is that formula? Is old capacity into 2 plus 2. Old capacity is 16. 16 into 2 plus 2, that is 34. If you print now, then it will print the capacity 34. Now let us come to this. SB dot ensure capacity 10. Guys, I have already string buffer with capacity 34. When we are calling ensure capacity of 10, which means make sure that the minimum capacity of string buffer is 10. We have already 34, right? We will at least bother. So there will not be any change in the capacity. If we print the capacity, it will print 34. But when we call SB dot ensure capacity 50, so what is the request here is make sure that the minimum capacity of the string buffer is 50. So what does it mean is SB dot ensure capacity. Make sure that the minimum capacity of the string buffer is 50. So we have the capacity of 34 and the requested capacity is minimum 50. Now we have to increase the capacity. It has to increase the capacity. How it will increase the capacity? Again the formula is old capacity into 2 plus 2. That is 34 into 2, 68 plus 2, 70. If we print the capacity now, it will print 70. Let me show you guys the demo. Ensure capacity. See this? I created the string buffer with the default constructor. The capacity is 16. Adding 6 elements, capacity will not grow, and we are adding more elements which is greater than capacity, then the capacity will grow using this formula, that is old capacity into 2 plus 2. Now the capacity is 34 and we are calling the ensure capacity of 10. Already we have 34 capacity, so you just ignore it. It will not change the capacity. But when you say ensure capacity of 50, we have capacity 34 and the request is to make sure that the capacity is 50, then it has to increase the capacity. How it will increase the capacity is 34 into 2 plus 2. Let me export guys. See, the initial capacity is 34, this one, and after adding this Sachin, there will not be any change in the capacity, and after adding his legend, the capacity will grow to 34. Even when we are calling ensure capacity 10, 34 will not change. But when we say ensure capacity of 50, it will grow. using 34 into 2, old capacity into 2 plus 2. Now the capacity is 50. Public char at int index. Guys, this will return the character at the specified position. Suppose in this case I have a string something like this, string Sachin, provide char at 2. I am providing the index. How this method will work is return the character which is present at second index. What is the second character present at second index? At 0 S, at 1 A, at 2 C. It will return C. Next one, public synchronized string buffer delete char at index. Provide the index, it will delete the character which is present at that index. Let me show you guys. Delete character at 3. Sys out SB. Guys, I am trying to print before deleting and after deleting. I am calling SB dot delete char at 3. What is the character which is present at third index? 0, 1, 2, 3. So it will delete H. So there is no H. Next one, trim to size. Public synchronized string buffer trim to size is used to trim the string buffer to actual size. Guys, whenever you are trying string buffer SB is equal to new string buffer, even when you are using the default constructor also, the string buffer will be created with capacity of 16. But if I don't want that much of capacity, what I need to do? Just call the trim to size method. It will trim the capacity equivalent to size. See, earlier the capacity was 60, and when I am calling trim to size, it is trim to size. What is the size? 0, because there are no elements. Let me add one few elements here. I am creating the string buffer by providing ABC, and I am printing the capacity. Now capacity is 16, but after calling trim to size, my capacity will sync to my size, that is 3. See, initially capacity is 19, 3 plus 16 19, and what is the size? 3. So after calling this method, the capacity will be synced to size. Public int length, just it will return the length of the string. What is the length in this case? How many characters are there? 3 characters. This is the length. Length method will return how many characters are present in string buffer. Next, public string substring begin index. this is my string buffer, guys. sb dot, I'm going to call substring. I'm going to provide only start index from 3. How it will work is, it will start taking the string from start to end, whatever. So 0, 1, 2, 3. From here to end it will return. Guys, substring means part of the string. How it will get that part of the string? If you two methods are there, overloaded methods of substring. For one method you just provide the start index from start index to end. In this case 0, 1, 2, 3. So it will return this. HIN Tindulkar. And another overloaded method is there. How this will work is start index and end index. What is the start index? H 1, 2, 3, 4, 5, 6, 7, 8, but 8 is exclusive. So it is going to print HIN space TEN. HIN T 8 0 1 2 0 1 2 3 4 5 6 7 8. So 8 is exclusive, HIN T. This is what we discussed, guys. Next, how to prove the string buffer is mutable. Guys, in last session we proved the string is immutable. We are going to use the same methodology. What we are going to do here is create one string buffer and print the address by calling the hash code method and trying to append some string. If it is immutable, then it will create the new string buffer. If it is mutable, then it will not create the new string object. Instead, it will add to the existing string. This is what I am going to do. String buffer SB is equal to new string buffer of Sachin. I am going to append SB is equal to SB dot append Tindulkar. First I will print hash code after creating the string buffer. After adding also I will print the hash code. And again I will take the string S1 is equal to Sachin, and I will add S1 is equal to S1 plus Tindulkar. Print the hash code on Sachin, and after adding print hash code. So in this case it will return hash codes or different hash codes here and here because strings are immutable. In this case here the hash code should be same because string buffer is mutable. Let me repeat once again, guys. I'm creating string buffer. I'm trying to add Tindulkar to Sachin. Since string buffer is mutable, Tindulkar will be added to the Sachin, that means existing object. It will not change the address of the object. So here and here it will print the same address. But in case of string, I'm creating Sachin and I'm trying to concatenate Tindulkar. Whenever you're trying to concatenate something to the existing string, it will create the new string, which means this string, address of this string, the address of this string, both are different. So obviously here and here it will return two different hash codes. Let me show you that. This is what we are discussing, guys. String buffer SB is equal to new string buffer of Sachin, printing hash code, adding Tindulkar, and printing hash code. In this case it should return same hash code value because string buffers are mutable. In this case strings are immutable. I'm creating the string, printing hash code. When I'm trying to add Tendulkar to Sachin, it will create a new string. Obviously the address here and the address here are different. Guys, see this? It is printing same address, and it is strings are printing two different address because strings are immutable, but string buffer is mutable. Let us take the performance test, guys. So what I'm going to do is I'm creating two methods, one per string, one per string buffer. I will iterate 10,000 times both the methods, and I'm going to measure how much time each method will take. Let me repeat it, guys. I will write one method per string and I will write the per loop. I will try to do the concatenation operations by iterating the per loop 10,000 times. And same thing I am going to do per string buffer, and I am going to measure the time taken by the first method and time taken by the second method. Let me show you this. This is the string. I am creating Sachin and trying to add Tendulkar. It will create the new object. Again, when I am trying to add Tendulkar, it will create the new object. So because strings are immutable, whenever you are trying to concatenate other string to existing string, each time it will create the new object. When I am trying to add Tendulkar, each time it will create the new object. Whereas string buffer, Sachin, trying to add Tendulkar will be appended to existing Sachin. Again I am trying to add Tendulkar will be appended to Sachin Tendulkar, etc. Let me show you guys how this will work. I am creating one method per string, public static string concat with string t is equal to Sachin. I am taking per loop, per int I is equal to 0, I less than 10,000 I plus plus. Each time I am trying to concatenate Tendulkar to existing one. I am writing another method for concat with string buffer, created the string buffer with Sachin. Each time I am appending Tendulkar, I am iterating 10,000 times. And I am going to measure the start time, calling the method, and end time. I am measuring how much time each method is taking. See guys, time taken by concatenating with string is taking 3151 milliseconds, but string buffer is taking only 4 milliseconds. Why? Because we are concatenating the string. For each concatenation, the string will create the new object. So for creating the object, it is taking time. That's why it is taking more time, and it will degrade the performance. So strings will not be useful whenever you have more concatenating operations. Then you go for string buffer. Let us see the differences between string and string buffer, guys. String class immutable, meaning that once the object is created, we cannot modify the content. String buffer class is mutable. Once after creating the object, you can modify the content. String is slow and consumes more memory when you concatenate too many strings, because every time it creates a new instance. That's what we saw just now. String buffer is fast and consumes less memory when you concatenate strings, because it will every time it will add the new string to the existing string, but here it will create new string for each time when you are adding the strings. String class overrides the equal method of object class, so you can compare the contents of two strings by equals method. String buffer class doesn't override the equals method of object class. Guys, we studied string buffer. Then did you see any drawback in string buffer? Yes, because almost all methods which are present in string buffer are synchronized. If you observe, almost all methods, main methods or all methods are depend as synchronized keyword. All methods are synchronized methods, meaning that whenever multiple threads are trying to execute, one after another thread only can execute the methods present in string buffer class. So that will again degrade the performance. That's why they introduced the string builder as part of Java 1.5. This is just a replacement to string buffer, but here all methods are non-synchronized, unlike your string buffer. That is the only difference between string buffer and string builder. Let me repeat, guys. Strings are immutable, string buffer is mutable, but string buffer is synchronized. Whenever more number of threads trying to execute the string buffer methods, one after another only can execute, which means no two threads can execute the string buffer method simultaneously. So it will degrade the performance again, though it is immutable. That's why they introduced the string builder as part of Java 1.5. It is just replacement to string buffer when we need more threads to execute simultaneously. Java string builder class is used to create mutable modifiable string. The Java string builder class is same as string buffer class, except that it is non-synchronized. It is available since JDK 1.5. Guys, let us see the constructors present in string builder class. As we discussed in string buffer, string builder also has three constructors. One default constructor, another one is we can provide the string, another one is we can provide the capacity. So whenever you are trying to create the string builder using the default constructor, it will create the string builder with capacity of 16. And whenever you are trying to provide the string, it will create the string builder with 6 plus 16 22 capacity. And third one is you can specify how much capacity string builder is required. In this case it will create 25. The demo is very similar to your previous string buffer, guys. Only thing is string builder methods are non-synchronized, whereas string buffer methods are synchronized. That is the only difference. Whatever you saw there, you can see here. Three constructors: default, you can provide string, you can provide capacity. Printing 16, 22, 25. Let us see the important methods in string builder class. Public int capacity is used to return the current capacity. Guys, I am creating string builder using a default constructor. And what is the string builder capacity now? 60. I am going to add 5 elements. It will not grow, the capacity will not grow, because the element which we are going to add is less than the capacity. Then the capacity still remains unchanged. When I am going to add more number of characters than the capacity, then the capacity will grow. How it will grow is old capacity into 2 plus 2, that is 34 in this case. Public string builder append. Guys, see, all string builder methods are non-synchronized because we are not using the synchronizer keyword here. If you see the string buffer methods, you will be using public string synchronized string buffer append. Let's see, the append method is used to append the specified string with this string. The append method has overloaded methods. I have a string builder with content Sachin, printing it. I am trying to add Tendulkar. So first print statement will print Sachin, second one will print Sachin Tendulkar. Public string builder insert. We are going to insert this string at this specified index. It is easy to insert the specified string with this string at the specified position. The insert method has overloaded methods. Let us see the insert, guys. So I have a string builder Sachin Tendulkar. I am printing it and calling the insert method providing 2 comma Mohan means Mohan will be inserted at second index. What is that? 0, 1, 2 here between A and C. Between A and C, Mohan will be inserted. See, guys, this is how insert method will work. Next one, replace start index, end index with replaceable string. The end index is exclusive, start index is inclusive. Replace string builder. I have Sachin Tendulkar. I am going to replace this string between 2 and 6. Between 2, 3, 4, 5, 6, but 6 is exclusive. Chin will be replaced with Mohan. Chin will be replaced with Mohan. Chin will be replaced with Mohan. Delete start index and end index, where start index is inclusive and end index is exclusive. So I'm creating string builder object with Sachin Tendulkar, printing it. I'm going to delete the characters between 3 and 7. 3 means 0, 1, 2, 3. 3, 0, 1, 2, 3, 4, 5, 6, 7. But 7 is exclusive. HIL space will be deleted. This is the original string, HIN space will be deleted. SAC Tendulkar. Reverse. Just call this, guys, it will reverse the string just like your string buffer. It will reverse the number of characters present in string builder class. Next, trim to size. Trim to size. Guys, I am creating the string builder object with Sachin. If you print the capacity will be number of characters 6 plus 16, 22. But trim to size method will trim your string builder to your size. Size is 6. Now here the capacity is equal to the size of the string builder, that is 6. So it will not waste the memory. If you are guaranteed that you are not going to add any elements to your string builder, just call this method. It will trim the capacity to its size so that you can save the memory. Public void ensure capacity. This is same as your previous case, that is string buffer. Let me create string builder SB is equal to new string buffer. New string builder. What is the capacity here? 16, and I am adding 6 elements. Capacity will not grow, and I am adding more elements. The capacity should be increased. How it will increase is old capacity into 2 plus 2, that is 34. Now if you call the ensure capacity of 10, guys, remember here what this method does is it is giving the instructions, hey string builder, make sure that you should have this much of capacity. That is, you should have minimum capacity of this. It has already capacity 34, right? And it is warning that has the capacity of 10. Just it will ignore. Capacity will not grow. But when we say SB dot ensure capacity of 50, hey, make sure that you should have this much of capacity. Then the capacity has to grow. How it will grow is 34 into 2 plus 2, that is 70. That is this one, guys. String builder with default constructor, capacity is 60. I'm trying to add 6 elements. Capacity will not go because the now elements which we are adding is below the capacity, and when we are adding more elements than capacity, that is 16, then capacity will grow. How capacity will grow is using the formula of old capacity into 2 plus 2, 34. And when we say ensure capacity of 10, capacity will not grow because capacity already 34. So when we call ensure capacity of 50, now the capacity has to grow. How it will grow? Old capacity into 2 plus 2, that is 34 into 2 plus 2, that is 70. See guys, first default capacity is 16. After adding Sachin, it is 16. After adding he is legend cricketer, 34. After calling this ensure method, capacity will not grow. After calling ensure capacity of 50, the capacity will grow to 70. Char at index, guys, is used to return the character at the specified position. If you call this method by providing the index, it will return the character which is present at that index. So this method is also present in StringBuffer and also string. I'm not going to explain this here. Delete char at. If you provide the index, it will delete the character present at that particular index. Length is used to return the length of the string, that is total number of characters. And substring, guys, if you provide the begin index or begin index and end index. If you provide the begin index from this to end, it will return the substring. If you provide the begin index and end index, it will return the substring from begin index to end index, where begin index is inclusive and end index is exclusive. Let us see the string builder mutability test, guys. It is very similar to your string buffer. Create the string builder and append some string and print the hash code. After adding, print the hash code. If this returns the same hash code here and here, after creating and after adding, then it should be mutable. Or string. Create the string and add something and print hash code, print hash code. Then if since string is immutable here and here, it will return the different hash codes. This is what, guys, string builder created with Sachin, printing hash code, adding something and printing hash code. Sachin, printing hash code and adding Tendulkar and printing hash code. Let us see, guys. So in first case, string builder, it is printing hash codes, same hash code before and after adding Tendulkar. Since string builder is mutable, here after and before adding Tendulkar, it is returning two different hash codes because it is two different objects, because strings are immutable. String buffer versus string builder. Let us see the difference between string buffer and string builder, guys. String buffer is synchronized, that is thread safe, which means two threads can't call the methods of string buffer simultaneously. String builder is non-synchronized, that is not thread safe. It means two threads can call the methods of string builder simultaneously. String buffer is less efficient than string builder. String builder is more efficient than string buffer. Guys, let us see the difference between string buffer and string builder. So in all general applications we will prefer the strings, but strings are immutable. When we need more concatenating operations, each time it will create the new objects because strings are immutable. So strings are not advisable to use whenever you have more concatenating operations. Then go for mutable class. What are those mutable classes? We have two. One is string buffer, another one is string builder. Though these two are mutable, string buffers are synchronized, string builders are non-synchronized. What is the synchronization? At a time only one thread can enter into the string buffer methods, one thread can execute because it is a thread safe, but it is slower than string builder, obviously, because if one thread enters into method, until it exits it will not allow other threads. But string builders are non-synchronized, but it is more efficient. So if we need mutable class but more accurate, speed is not a matter, then go for string buffer. If you need mutable class but speed is a matter, not accuracy, then go for string builder. Thanks guys, thanks for watching this video. Please subscribe to my channel and share this video with your friends. Thank you very much.